A Portland Community College Mathematics telecourse. A course in arithmetic review produced at Portland Community College. After a few points of minor adjustment, it will turn out that division of two fractions is about as easy as multiplications. But let's look at a few other points first. First, an obvious fact, but we need to think about it. If you write any number over 1, it's still the same number you started with. If I take the whole number 5, I can write it as 5 over 1, and it's still the same number. Bear that in mind. That's going to be important in a few moments. Now, a special definition or vocabulary. If you have a fraction and you were to write that fraction, as most of us say, tipped upside down, really the numerator goes to the denominator and the denominator goes to a numerator to form a new fraction. We call that fraction the reciprocal of the other fraction. Now, in some algebra books, it will be referred to as a multiplicative inverse. In sloppy language, reciprocal is simply when a fraction has been tipped upside down. The more formal language, the reciprocal of one fraction is that fraction with the numerators and denominators interchanged. An example, if this is a fraction, its reciprocal would be 4 over 3. The reciprocal of this fraction is 5 over 3. An interesting 5 over 8, isn't it? An interesting side note is if this is proper, its reciprocal will not be. On the other hand, if it's improper, its reciprocal will be proper. Just a nice observation. Couple more. Now, if I wish a reciprocal, I must have it expressed in fraction form. Now, recall the first point we made, that if I have a whole number, I can write it over 1, and it's still the same whole number. Now, if I wish the reciprocal of that, I can interchange numerator and denominator and get 1/5. Now, note we say equal here because they are indeed equal. These two are not equal, so don't put any equal sign there. Now, it's the same thing here. I reciprocate fractions. This is not a fraction, so I change it to its equal valued improper fraction form. So 2 times 3 is 6, plus 1 is 7 over 3. Now that it's in fraction form, I can invert it or reciprocate it, and I get this. Again, these are equal, but these are not. But these are reciprocals of each other, as are those. Note that 0 has no reciprocal. First, if I write 0, I may express it as a fraction by writing it 0 over 1. But if I were to invert it, I would have 1 over 0, which is division by 0, which is not possible from a few lessons back. So this simply is not possible. So 0 has no reciprocal. Now, a special property between a number and its reciprocal. The product of a number and its reciprocal is always 1. Example, if I have 3/4 and I take its reciprocal and multiply, you can see that this times this is over this times this, and anything over itself is always 1. Anything divided by itself is 1. Now, we could have also said it this way. Since I'm multiplying, I'm allowed to cancel. 3 into 3 is once, into 3 is once, 4 into 4 is once, and once again. 1 times 1 is 1, 1 times 1 is 1. But the important thing is any fraction times its reciprocal will always be 1. No exception except for 0, which has no reciprocal. Now we're ready for division of fractions, and it's simply this. Invert the divisor and multiply. The divisor is always the fraction which follows the division. So it says to invert the divisor. That's 22/15. And then multiply, which told me in effect to leave this alone. Now let's restate that. Leave the first number alone. You could say change the division to multiplication and use the reciprocal of the divisor. Now if you're multiplying, you have permission to cancel. So in this case, 5 goes into 5 once, into 15 3. 2 goes into 6 3 times, into 22 11. 1 times 11 is 11. 3 times 3 is 9, or 1 and 2 nines, if you want it written as a mixed number. Now note, in this case, I am not allowed to cancel here because that's not multiplication. Remember, we said be very cautious. You can only cancel if you're multiplying. So in short, all divisions are really multiplications of the reciprocal of what followed the division. One more example. If you're going to divide, leave the first number alone. That's your dividend. Multiply, take the reciprocal of the divisor as your second factor in your multiplications. Now that you're multiplying, check to see if there's any cancellation. There is there. 5 into 5 goes once, 5 into 10 goes twice. There is no more, so multiplying the tops for the new top, the bottoms for the new bottom, I'm done, it's reduced. So in short, if you know how to multiply, if you know what we mean by reciprocal, you can divide. Because as it turns out, we don't really divide. We trade a division problem for a multiplication problem, which is guaranteed to have the same answer to the problem we never did. Interesting, isn't it? Those of you who might go on into number theory, you will of course prove why this is so, and it's very interesting and leads into many other things. A couple of special cases. If one of your two numbers is not written as a fraction, then simply write it as a fraction by the note we started with. You can write any whole number over 1. It's in fraction form now, but it's still 3. Okay, leave the first alone. Change to multiplication. Take the reciprocal, which we can say invert or reciprocate. Check for cancellation. Then multiply. You're done. It's reduced. That's simple. One more. If either one is written in whole number form, write it in fraction form. Always leave the first one alone. Divisor becomes multiplier. Take the reciprocal of that which followed the divisor. Now do this instead of that. Check for cancellation only when you have multiplication, never up here. So in this case, I can cancel here, and my answer is 10 over 1, which is just 10. Okay, now it's a common mistake for many people to forget which one they're inverting or reciprocating. And they forget and invert this instead of this. Always the divisor, always the one which follows the division. So division is actually as easy as multiplication because, in fact, it's a special case of multiplication. Let's work just a few more problems to convince ourselves that this process is really a very simple one. Here we have two different problems, 2/3 being divided by two different fractions. Now, Division of fraction is simply this. Leave the first in the division process alone. The division is going to become a multiplication problem by taking the reciprocal of the number which followed the division sign. Now note our use of language. We took the reciprocal of 6/7, which is 7/6, or you can say I tipped 6/7 upside down, or I could say take the multiplicative inverse of 6/7, which is 7/6. So tipping upside down, reciprocal of, multiplicative inverse of are all three phrases for the same process. Then once it's a multiplication problem, we're in business. When we're multiplying, then and only then do we check to see if there's cancellation. And there is here between the 2 on top and the 6 on the bottom. When there is no more cancellation possible, you know that the product, the results of your multiplication, will be reduced before you even start it. So my answer, 7/9. So there's our basic rule for division of fractions, and it's important to realize right now at the beginning that that rule never changes. So you always leave the first alone, always change the division problem into a multiplication problem by taking the reciprocal of the divisor as my multiplier. So here I would leave the 2/3 alone, change the division to multiplication, reciprocate 1/4, which becomes 4/1, and then multiply, first checking to see if there is any cancellation, and there isn't. So 2 times 4 is 8, 3 times 1 is 3, and I can change this to a mixed number, which would be 2 and 2/3. So sometimes your results of your division is itself a fraction less than 1, that is a proper fraction. Sometimes the result is an improper fraction, which means it could also be expressed as a mixed number. No matter how the answer comes out, and no matter what kind of divisors or dividends you had, the rule is the same. Leave the first alone, change to multiplication, reciprocate the second, multiply. Also be aware that there will be a temptation, if you're not thinking, to cancel when you shouldn't. Remember, you cannot cancel across any symbol except multiplication. So here I'm canceling across the multiplication, that's allowed. Here I'm tempted to cancel across division, that's not allowed. Got that? Let's do 2 more. In this one, I'm dividing a fraction by a whole number, and here a whole number being divided by a fraction. The point we're trying to make is the same as in the last 2 problems, that what the numbers are does not determine the rules for division. They stay the same forever. It's just that if we have a whole number anywhere, anytime, in any problem, if we wish, it can be changed into fractional form by writing it over 1. And it's important to realize this did not change its value. 6/1 is still 6, and 5/1 is still 5. But now our rule for division is to leave the first alone. The division becomes the multiplication, and you reciprocate the divisor. That is the number which followed the division. Then, since it's now multiplication, it's fair to check for cancellation possibilities. Then multiply the old tops to get the new top, and the old bottoms to get the new bottom, and you're done. This is the results of 3/4 being divided by 6. Now over here I'm dividing the whole number by the fraction rather than the reverse of this, but the rules for division stays absolutely the same. So we leave the first number alone. Division changes to multiplication. Reciprocate the divisor, that is the number which followed the division. Now that you have multiplication, check for cancellation. There isn't any. Then multiply the old tops to get the new top, the old bottoms to get the new bottom, and it's an improper fraction, but a reduced improper fraction. However, frequently we want you to change this to a mixed number by taking, in this case, 35 divided by 2, and we would get 17 and 1/2. This process of going from an improper fraction to the mixed number form and the mixed number format back to the improper form should be a very automatic procedure to you now. If it is not, it's appropriate that you stop after this lesson, go back to that lesson, and do some more of these until you are comfortable, smooth, and accurate at it. Because future lessons will be going back and forth just routinely and very quickly. Now that part of this lesson is quite easy. So let's use a few moments of this lesson to once again do some reviewing on finding the least common multiple of a series of numbers. Recall at the end of the last lesson, we had you come to grips with the idea finally that least common multiple means what's the lowest number that each one of these will divide into. Multiple meant find the multiples of these, and that it were better to start with the largest. 14 is certainly the lowest that 14 will go into, and its second multiple was 28, which now 7 will divide into, but 5 won't. If we find the next multiple, which is 14 added to this, which would be 42, since 7 goes into this, it still goes into this, but 5 still won't. If we take the next multiple, which will be 14 plus 42, which is 56, 5 still will not. If we take the next multiple, which will be 70, now finally we can see that 5 will. So we have a multiple of 14 that 7 will divide into, which means it's also a multiple of 7, and that 5 will also go into, which tells me it's also a multiple of 5. We mentioned there are many other multiples. 140 is divisible by each of these. 210 is divisible by each of these, and so on. There's an infinite number of them. But you see, even for these fairly simple numbers, using this traditional approach to find that least common multiple can be rather messy. And we had mentioned last time that to find the least common multiples of something like this, by this method, is completely out of question. It's simply too involved and would take too much time. So in Chapter 2 and through these reviews, we had found an alternative way of doing this that's more methodical. And part of that procedure will require that we are quite good at the following concept. That is, to prime factor a given number and to write that prime factorization in exponential form. Do you recall this from Chapter 2 and perhaps a few previous review lessons ago? It's very important that you're on top of this. We don't mean that you can do it, but that you're really right on top of it. So to prime factor something means to find repeatedly all the prime numbers that will divide into 108 in this case. So to do this, we need a list, either in memory or on paper, of prime numbers in sequential order. Here is such a very partial list, and we can see that the lowest one, 2, will certainly divide into 108. dividing 108 by 2 either by hand or calculator, we get a quotient of 54, which is still divisible by 2. So we can divide by 2 a second time. That's 27. But 2 will no longer go into 27, but the next prime number, in this case, will. So 3 goes into 27 9 times. 3 still goes into that quotient until finally I get a quotient that is itself a prime number. So what we are saying now is that 3 times 3 times 3 times 2 times 2 is simply another way, a prime factored way of writing 108. We could say that 108 and 2 times 2 times 3 times 3 times 3 are just two ways of saying the same amount, the same number. However, we also learned that rather than writing 2 times 2 this way, we could write it as 2 squared, or 2 with an exponent of 2. This to counting how many factors I have. So I have 3 3's being multiplied, so I have the exponent 3 to indicate I had multiplied 3 of them together. So this number is 108 in prime factored form and written in exponential form. Do you recall it? I hope so. This is going to be a critical item in a few more lessons, along with that notion of least common multiple. So let's do one more. Let's try this one. And please note that this is one of the two numbers we've been dragging along through quite a few lessons now, claiming that very shortly we will be prime factoring these and finding the least common multiple of these two in a rather routine manner. So to prime factor any number, we start or begin a series of divisions, but divisions only by prime numbers. So we notice that the lowest prime number 2 will divide into here. We can note that by the divisibility test. And again, you can do the division either by longhand or by use of a calculator. But if you were to divide this, you would get 588. And we note that it is still divisible by 2. So we divide again by 2, the quotient this time. Doing so, we get 294, which is still divisible by 2. Dividing that by 2, we get 147, which no longer being even is no longer divisible by 2. So we try the next prime number, 3, either by hand or by calculator. But our divisibility test tells us that 3 will divide into 147, since the sum of the digits, 1 plus 4 is 5 and 7 is 12. So since the sum of the digits is divisible by 3, so is the number itself. So dividing this by our next prime divisor, which is 3, we get 49. And of course 49 we can see is divisible not by 3 or 5 but 7. So dividing it by 7, we get 7, which is itself a prime number. So now we can see that 1176 is 2 to the third power times 3 to the first power times 7 to the second power. So here we have 1176 in prime factored form written in exponential form. That's the form that we're going to use in the future lessons to find the lowest common denominator of very complicated fractions. But this will make it a very routine affair. One more. Let's prime factor the other of our two given large number, 1386. Again, just by observation in this case, we can tell that 2 will divide into it. Dividing it by 2, we get a quotient of 693. We can tell, since it's not even, that 2 won't work anymore. So now let's check 3 by the divisibility test. 3 goes into 6, into 9, into 3. Hence 3 will also go into the sum. So 3 will go into this. Now, of course, if you're doing this with a calculator, it's very fast, isn't it? Dividing this by 3, we get 231. And again, our divisibility test tells us that 3 will divide into this. Goes into 7, leaving 21. 3 goes into 21 7 times. And we can see that 3 will not go in any further. But we can see that 7 will. That goes in 11, and 11 is a prime number. So 1,386 prime factors into the number 2 to the first power times 3 to the second power, or 3 squared, times 7 to the first power times 11. So we now have this prime factored. So prime factoring a number is as simple as division by simple numbers, which we call primes in this case. So as you move into the next and the following lessons, do whatever review you have to do so that you can feel very comfortable with prime factoring any given number and writing it in exponential form. In the meantime, don't forget our main lesson. Division is just this simple. First, avoid the temptation to cancel where you cannot. You cannot cancel across division. So division means leave the first number alone. The division problem changes to a multiplication problem by reciprocating the divisor. That is the number that followed the division. Then simply perform the simple multiplication. But now that I am multiplying, I can check to see if there's any cancellation possible, as there is here. 2 goes into 8, 4. 2 goes into 7, 7 times. I cannot cancel here because they're both on top. So I multiply the old tops to get the new top, the old bottoms to get the new bottom. And I have my answer, in this case, in improper fraction. If we wish it in mixed number form, this would be 49 divided by 12, which is 4 and 1/12. So division is that simple. So enjoy this particular simple lesson. Recall the review, and we'll see you again in the next lesson. Until then, this is your math host, Bob Fennell. Good luck.